Okay, here we go. Let's continue with 3.4 using square roots to solve quadratic equations. So the other day in class we did talk about solving question A here, example A, solving by square rooting. So we're going to do question B here. And like I did mention, so when we come up with questions that we cannot factor, if we can't factor them, we can't solve them. So this here, if I were to expand this, then I would have x minus 4 times x minus 4, which expands to x squared minus 8x plus 16 equals 12. And when I move the 12 over by subtracting 12, I get 8x squared minus 8x plus 4, which is not factorable. So we need to have a tool or some method in order to still solve these, although they are non-factorable. One of those tools is using square roots. And one of the steps to getting to that point is completing the square. So this is the precursor to that, because once we get our polynomial looking like this, we can solve this by square rooting, just like we did with the previous example. So if we continue to solve this one by square rooting, we're essentially going to say, well, if this is x minus 4 squared is equal to 12, I can square root both sides. To simplify, this would leave me with x minus 4 on the left-hand side and the square root of 12 on the right-hand side. This is where you should be thinking, hey, wait a minute, square root of 12, well, that simplifies. Okay? If you need to, then you're doing your tree, you're doing your prime factorization tree, 2 times 6, 2 times 3, so the square root of 12 is 2 times 2 times 3. There's a pair, because we're doing square roots, it gets kicked out, get a 2. We're left over with 3. So this simplifies to 2 square root 3. So now I have x minus 4 is equal to 2 square root 3. But remember, the beginning of this unit, we started to say, hey, when we do the square root, when we do the square root of a value, we get that plus or minus version. Okay? So this is where we now need that version, or we need that both of those versions, not just the principal root. So this is now plus or minus the square root, or 2 square root 3. To continue solving for x, we add 4 to both sides. So now I get x, those will cancel, is equal to 4 plus or minus 2 square root 3. There's the solution that we get to verify. So now we go through our verification steps. So we have two solutions here. We're going to verify. I'll switch colors. 4 plus 2 root 3 and 4 minus 2 root 3. So we go back to our original equation. X minus 4 all squared is equal to 12. We substitute in 4 plus 2 root 3 for x. So I get 4 plus 2 root 3 minus 4 squared is equal to 12. By eliminating the brackets around the 4 plus 2 root 3, we're going to bomb in that imaginary 1. So I get 4 plus 2 root 3 minus 4 squared is 12. Well, 4 minus 4 is 0, so now I just have 2 square root 3 squared is equal to 12. Well, 2 square root 3 times 2 square root 3 is 4 square root 9. Square root of 9 is 3. And 4 times 3 is 12. Verify. And we verify the other version as well. 4 minus 2 root 3 into the same equation. Oops, not 2. Substituting in 4 minus 2 root 3 and for x, I get 4 minus 2 root 3 minus 4 equals 12. Getting rid of that bracket on the inside, multiplying in or distributing that 1. I get 4 minus 2 root 3 minus 4 squared equals 12. Those will cancel. I'm left with minus 2 root 3 squared equals 12. Negative times a negative is a positive. 2 root 3 times 2 root 3 is 4 root 9, just like the other side. Square root of 9 is 3. 4 times 3 is 12. Verified. So now we verified. Okay? So we can still do the verification process if we have a polynomial in this form. Now what we need to do is get our polynomial into that form. So let's go on to the next page, the next example, and we'll see what we need to do. Okay, so over to the next page. Example 2, solving by completing the square when a is equal to 1. So that means that this value in front of the x squared term is a 1, because the process changes a little bit if that's not a 1. Okay, so we have solve x squared minus 10x plus 3 by completing the square. Okay, so this book approaches this a little bit differently than I would. It's not going to be a huge deal. We just need to make sure that we remember a particular step when we get to a later unit, later section in the next unit for quadratics. Okay, so let's start with x squared minus 10x plus 3 is equal to 0. The first thing we need to do is have this constant on the right-hand side of the equal sign. So we need to move that constant. We move that by subtracting 3 from both sides. So those will cancel. I'm left with x squared minus 10x is equal to negative 3. Actually, I'm going to move that, and you'll see why I'm going to move that in a second. Equals negative 3. So now what we want to do is we want to add some kind of constant, a new constant right here. And of course right here, because whatever we add to one side of the equal sign, we add to the other. We need to add a constant so that this polynomial on this side factors to a perfect square. To determine what that constant is, you take the b term, that value right there, negative 10, you divide it by 2, which gives us negative 5, and then you square that answer. Negative 5 times negative 5 is 25. So we are going to add 25 to both sides of the equal sign. And you'll see as soon as we do that, once I do the next step, that it's going to factor to a perfect square. Okay, so now I have x squared minus 10x plus 25 is equal to negative 3 plus 25 is 22. Now we look at this and we say, well, does this factor? And it should. We want it to factor to a perfect square. So remember, we're looking for two numbers that multiply to 25, add together to give negative 10. Hopefully you can do that by inspection at this point. We know that our numbers are going to be negative 5 and negative 5. Negative 5 plus negative 5 is negative 10. Negative 5 times negative 5 is 25. So that's going to be x minus 5 is equal to 22. Now these are both exactly the same, so this can be rewritten as x minus 5 all squared is equal to 22. And you can see we're at exactly the same point as we were with our previous example over here of x minus 4 squared is equal to 12. Now we can go through all of those same steps to continue to solve. So if x minus 5 squared is equal to 22, I can take the square root of both sides. That's going to leave me with x minus 5 is equal to plus or minus the square root of 22. 22 doesn't simplify. That's 2 times 11, so that doesn't simplify at all. So I'm going to add 5 to both sides. That's going to give me x is equal to 5 plus or minus the square root of 22. There's your solution. And now again, we can go through that whole verification step. For simplicity and a little bit of extra speed here to get through this, you should be able to verify it. You should be able to verify that. Okay? We're not going to at this point. This one might be a little bit more complicated to verify, but you should be able to. Okay? I probably wouldn't even ask you to do that verification on a quiz or a test. I'd rather you just get to that point. So now we can move on to example 3, and we can see what happens or what we have to do in order to deal with values of a that are not just 1. So now we have negative 1/2, and now we have 3. Okay, so let's start with, you know what, let's start with b, because b is a whole number. We'll get the idea of the process first, then we can go and deal with that fraction. Okay? So again, remember the first step is we need to have this constant on the other side of the equal sign. So I'm going to subtract 5 from both sides. Those will cancel. I'll be left with 3x squared plus 9x is equal to -5. Totally wrong color. Sorry about that. Actually, I'm going to fix that. Maybe fix that. There we go. 3x squared plus 9x is equal to -5. Now, when we have this term in front, or this constant or coefficient, I mean, in front of the x squared term, we have an extra step because we need that x squared term to be 1. So in order to do that, we need to factor out that value. Whatever that value is, we need to factor that out of the left-hand side of our equal sign. So if I factor out a 3, I am left with x squared plus 3x. And again, I'm going to write this bracket a little bit further over here is equal to -5 so that I can see what our next step is. Okay? So I've just factored out a 3. The 3 needs to stay there. Don't multiply it in anywhere. Don't divide it anywhere yet. Just leave it right there. Now I think, well, I need to add some constant in here such that this polynomial will factor into a perfect square. To determine what to add in there, I take this b term, I divide it by 2, and then I take that, I'm going to leave that as a fraction, 3/2. Then I take that and I square it. 3/2 squared, 9/4. So I'm going to add 9/4. Because I add 9/4 there, I have to be really careful. Okay, so actually I probably should back up a little bit. This book does this a little bit differently than I normally do, and I kind of missed a step. What am I going to do here? Yeah, sorry, I'm going to back it up a little bit. Back it up to where we factored out the 3. And that's my apologies. That's the difference between the process that I do and the process this book does. So I'm going to just stick with the book just to make sure that we're following the same. So at this point, we've factored our 3 out. I know I said to leave it there. I'd be happier if we did leave it there because we need it there later in a unit or later in the next unit. Now we actually want to divide this 3. We divide this 3 here, we divide it on the other side. So this is what we get. X squared plus 3x is equal to -5/3. These will cancel. Those will reduce to 1. Okay, sorry about that. Now I do that same process. What do I need to add in order to make this a perfect square? I take the 3, I divide it by 2, leave it as a fraction, 3/2, do not use decimals, and then I square it. 3/2 squared, 9/4. 9/4. Because I add 9/4 to the left-hand side of the equal sign, I need to add 9/4 to the right-hand side of the equal sign. So I am left with x squared plus 3x plus 9/4 is equal to, somewhere you're going to do some math, you're going to go -5/3 plus 9/4. My common denominator is 12, so I've got to get this on 12, and this on 12. So 3 times 12 is 4, -20. Let's multiply 3 by 4 to get to 12, so -5 times 4 is -20. I multiply 4 by 3 to get to 12, so 9 times 3 is 27. So I have -20/12 plus 27/12 is equal to 7/12. So my right-hand side of the equal sign is 7/12. I'm going to make my 9 a little bit nicer over here. Now, this should factor. You'll be looking for two numbers that multiply together to give 9/4, but add together to give 3. But the beauty is that we already know what that number is. That number is whatever this is right here. Right before you square it, whatever you took that b term and divided by 2, that's exactly what this is going to be. So this is going to be x plus 3/2, x plus 3/2. 3/2 times 3/2 is 9/4. So they still multiply together to give 9 over 4. 3 over 2 plus 3 over 2 is 6 over 2, which reduces to 3, which gives you that middle term. So that's a simple way to determine what value these are going to be. Is equal to 7 over 12. Now this simplifies to x plus 3 over 2 squared is equal to 7 over 12. And then we do the exact same thing we've done before. Square root both sides. So I get x plus 3 over 2 is equal to plus or minus 7 over 12 under a root sign. And then I subtract 3 over 2. X is equal to negative 3 over 2 plus or minus square root of 7 over 12. And I'm okay if you leave it right there. I know the book might do something a little bit different. There might be some rationalization of some radicals and stuff, but that's okay right there. And that's a long, there's the whole answer. So question A is absolutely no different, except that when we factor something out of the left-hand side, it's got to be that fraction. And at this point, we should know how to do that. Okay. So we'll go back up here. Question A. Again, we want the constant gone. So I'm going to add 1 to both sides. So I add 1 to both sides. I get negative 1. Oops, wrong color. Negative 1 over 2 x squared plus 6x is equal to negative 1. I want this x squared term by itself. I want it by itself, so I want it to have a coefficient of 1. So I need to factor out a negative 1 over 2. So if I'm factoring out a negative 1 over 2, dividing negative 1 over 2 x squared by negative 1 over 2 just gives me x squared. Maybe you know what 6 divided by negative 1 over 2 is right away, which would be great. Otherwise, you're going 6 divided by negative 1 over 2, which is 6 over 1, copy, dot, flip, 2 over 1. If you put the negative on the bottom, it's not a big deal. I know some of you will, I know most of you will, is equal to 12 over negative 1, or just negative 12. Okay? So this becomes minus 12. X equals negative 1. Now we need to get rid of this negative 1 over 2, so we're going to divide by negative 1 over 2, divide this side by negative 1 over 2, we get x squared minus 12x is equal to, again, negative 1 divided by negative 1 over 2, it's negative 1 over 1 times 2 over negative 1. Negative is positive, that gives me 2 over 1, or just 2. So this is 2 on this side. Oh, there should be an x there. Now I think to myself, well, x squared minus 12x, what can I add in here that makes that a perfect square? Again, take your negative 12. Doesn't have to be negative, you're just worrying about the number because it's always going to be plus. 12 divided by 2, which is 6, and square 6, which is 36. So I'm going to add 36 to both sides. So I get x squared minus 12x plus 36 is equal to 38. To be honest, I'm going to pause my video right here and check my stuff because something's not looking right to me. Okay, I found it. I'm going to go way back here. Hopefully you figured that out on your own and you were screaming at the computer. I added 1 here, but I subtracted 1 here. This should be a plus 1, which makes this a positive 1, which makes this a positive 1. As I do my math over here, this should be a positive 1. This should be a positive 1, making this a negative 2. So this should be a minus 2. This should be a minus 2. And 36 plus negative 2 should be 34. This should be a 34. Doesn't affect much of the question till here, so this should be a 34. No, that shouldn't be a 34. That's a 36. But this side, 34. Okay, so now we're good. Now we're golden. So now I look at this, I say, well, what does that factor to? I'm looking for two numbers that multiply to 36, add together to get negative 12. Hopefully you can see that that is x minus 6. X minus 6 equals 34. Or x minus 6 squared is equal to 34. And then we continue to solve. Square root both sides. I get x minus 6 is equal to plus or minus square root of 34. Add 6 to both sides. And I get x is equal to 6 plus or minus the square root of 34. And that would be that one done. Sorry for the mistake in there. Okay, so all I want you to do today is try to practice some of these on the worksheet that the TOC is going to be handing out. Try and get some of them done. Give me your best effort would be awesome. Then we'll pick this up again tomorrow. Okay? All right, we'll catch you next time.